Hi, I'm John Masick, Senior Vice President of Bearing Service. I'm a certified bearing specialist, which is a program within the Bearing Specialists Association. Today, we're going to be talking about lubrication. Materials have been provided by the organization Lubriplate, which is a member manufacturer of BSA. Without further ado, let's get right into it. So, why do we need lubrication? So if we look at the bottom of this slide where it shows non-lubricated, the heading is non-lubricated. You'll see down here that there's asperities, which are high points of the steel where the steel would typically meet. And if you have two surfaces, let's say this is the raceway down at the bottom and this would be the ball here. Under a microscope, you're going to see kind of what looks like a mountain range and perhaps some valleys. And if there's no lubrication, what you're going to see is you're going to get metal-to-metal contact in the low points of the asperities on the top with the high points on the bottom. And what that will do is it will cause significant wear of the steel. So what you want to see instead is if you put a lubricant with the right viscosity between the two metal surfaces and separate those, you will have much, much less wear and much greater life of your bearing. So I mentioned the word viscosity. What's viscosity mean? So viscosity is a measure of resistance to flow of a fluid at a specific temperature. But in English, something with a high viscosity, something like pancake syrup or molasses in the wintertime, would pour very, very slowly. The fluid would take much longer to flow. And something with less viscosity, like water, will flow very, very easily, even if the temperature should fluctuate. And so matching the right viscosity to the right application is going to be very important when we're choosing a lubrication for a particular bearing. In general, there's some rules of thumb related to type of lubrication and the viscosity and how it's affected by temperature. We know from just maybe working on our cars or using oil that might be in your automotive engine, that when that oil heats up, it thins out. And if the oil is in your crankcase in the wintertime and it's cold outside, like it is in Michigan, it will become thicker. And so we know that sometimes the oil viscosity needs to change depending on the season. And depending on the viscosity index of an oil, which is kind of the measure of how much thicker or thinner it gets under a certain temperature fluctuation, that's going to help dictate. Knowing that temperature range is going to help dictate what kind of lubrication we're going to want. One of the ways that you can help your lubrication is to use synthetics or viscosity index improvers, which will help reduce the amount of change in the viscosity of a particular lubricant under wide temperature fluctuations. The way you measure lubrication viscosity, there's several different scales. One of them is something called kinematic velocity, or viscosity, excuse me. One of them is called kinematic viscosity, which is a ratio of the dynamic viscosity to its density. So it takes into account the mass over volume, which is density, along with the flow rate that particular liquid's going to have. And this is under no force at all. And by doing the math in terms of determining the viscosity with its density, you come up with a scale called centistokes, which is abbreviated CST. And this is just one viscosity measurement that's used by tribologists, which are people who study and manufacture lubrication. And the centistokes scale is one that tends to be more metric in nature, used by organizations outside the United States. Another real popular viscosity measurement is SUS, or Seybolt Universal Seconds. And again, it's the time in which it takes a heated oil to empty from a vessel, which basically takes into account the flow rate of that oil or any type of lubrication. Seybolt Universal Seconds, which would be abbreviated SUS, could also be sometimes abbreviated as SSU or USS. It tends to be used much more commonly in the United States. There are other viscosity classifications that are also used, however. One is ISO, which is the International Standards Organization. They have a scale. AGMA, which is the American Gear Manufacturers Association, also has a scale that is been used in the past, a lot of times for industrial gearbox applications or for gear oil specifically. And then lastly, the Society of Automotive Engineers, which tends to be more non-industrial but more automotive. They also have a scale, and many of us are kind of familiar with that. If you were ever a person who's ever changed oil in their car, and in the summertime you might buy some 20W50, but in the wintertime you might buy some 5W20. Those are the types of scales that are used by SAE. Here's a pretty good synopsis of all of these different scales. On the left, you'll see the kinematic viscosity, which is abbreviated in centistokes, at 40 degrees C. And 40 degrees C is a common measurement of how much, say, an electric motor might be able to rise. That's a common occurrence for bearings when they're heating up in an industrial application. You might be able to see that kind of raise in temperature internally. On the far right is the Sabel universal seconds, which is expressed at 100 degrees F, which is more the United States. Now, one of the things you'll see there is if you're looking at ISO, AGMA, SAE, or the SAE crankcase, there's vastly different scales. And one of the things that you got to be aware of is what index you're using. For instance, if I have a 50 and we don't abbreviate or tell somebody that is centistokes, that could easily be miscommunicated to a customer saying they needed 50 weight SAE crankcase oil, which is somewhere around 1,000 Sabel universal seconds. And if we look across the page, more like 200 centistokes. So it would have 4 times the viscosity or thickness as it would. So it's very, very critical that when you're discussing oil viscosity, that you express what scale that you're utilizing, which is exactly what this slide is referring to. So if you have an OEM equipment manufacturer and they're specifying an oil and they say it's a number 50, it's important to know what scale that they're using. And if you incorrectly provide that information to your customer may be very dissatisfied because you've given them potentially a thinner or a thicker oil, depending on the scale that you're using. So most companies now are probably moving towards ISO. ISO tends to be a more universally accepted scale system in a lot of different measurements, but certainly in the bearing industry, ISO is becoming more and more common. So the ISO viscosity system is being utilized by many companies. This gives you an idea of the composition of what we call grease. And I'll give you a real brief definition of what a grease is. Grease is oil and thickener. And thickener could be a variety of different things. It could be a synthetic thickener, or it could be a naturally occurring thickener, which we're going to discuss in a minute. But if you were to break down the weight of a particular grease, you'd see that the majority of the weight is actually lubricating oil. That lubricating oil would be suspended in some kind of thickener, and then you may put some additives in there to allow you to have some additional properties that the base oil itself may not have. There are many different types of grease in terms of thickeners. And on this page and the next one as well, we're going to kind of discuss a little bit of what common types of thickeners or bases are going to be available. Probably the most common is lithium. If anybody has ever repaired, let's say, a boat trailer or even an automotive wheel bearing, back when you could do those kinds of things, a straight lithium is a great grease because it is waterproof. It actually has good load capability. Downside is it doesn't handle really super high temperatures, so it should not be used over 275 degrees F. If you need your lithium to be a little more resilient, then you can go to a lithium complex. Complexes tend to have additives in them that allow for the grease to have extended temperature ranges, whether that's higher temperature or lower temperature. And lithium complexes are very, very common. Both lithium and lithium complexes are commonly used in bearing pillow blocks by a lot, in mounted units in general from a lot of different bearing manufacturers. It says on lithium complex it doesn't have H1 approval. What H1 approval is, it's a USDA approval rating that stands for the ability of that lubricant to have incidental food contact. So if you were in a plant where they're doing food processing of any kind, whether that's meat processing or other types of human consumables, if the grease accidentally spilled on the food in low quantities, it would not damage the food, and somebody could literally eat it without having any ill effects. But this particular lithium, or most lithiums, are not food grade greases just by themselves. The ones which are commonly use the base of aluminum complex, and that gives a very wide temperature range as well as good water resistance, and it does allow that grease to have H1 approval. Polyurea has now become probably the most common type of grease, particularly in most ball bearings that are shielded or sealed from a bearing manufacturer. Virtually everybody today is using a shear stable polyurea, and we'll talk a little bit more about that in a slide coming up. But the advantages of a polyurea are that it is waterproof. It also is the grease of choice for electric motors, and it has good wide temperature range. There are some other greases that are probably less commonly used today. One of them is an organophilic clay, which is sometimes used in food applications, sometimes in oven conveyors, where there might be incidental food contact. And again, like an aluminum complex, it's got that H1 rating, or the ability to have that. And it's also, since it's used in an oven, has a little higher temperature range than some of the other greases do. Calcium complex is another one that probably not nearly as popular as it once was. Again, it's good water resistance, H1 approval, so it can be used in food. And it tends to be a grease that the steel mills and paper mill people like, because primarily on the paper mill side, the water resistance, and on the steel mill side, more for the temperature range. Calcium sulfonate, again, good corrosion resistance. High EP. EP stands for extreme pressure. Back in that slide where it shows the tubes of grease and it had a high EP rate, or it had, the additives. EP, or extreme pressure additives, are a common additive into a tube of grease. That enables the grease to have more shear capability. Shear capability is a grease's ability to handle load. And so a lot of calcium sulfonates are used in food applications or high load applications. Again, good temperature range on this one. And then lastly, sodium is another lubrication type or base. Pretty inexpensive, not very common any longer. It is a water soluble grease rather than a waterproof grease, which means that it can take a small amount of water, like condensation, and absorb it in the grease, but it can't really handle a washdown application. And sodiums also have a very low temperature range, so it's kind of an out of favor grease that's not very common anymore. In terms of greases, most industrial products have some type of governing body that kind of oversee and kind of prescribe certain characteristics of the grease and internationally standardize it. The one that covers grease is the NLGI, which is the National Lubricating Grease Institute. And one of the NLGI measurements is related to the overall flow rate or viscosity of the grease, or pumpability of the grease. So it's not really it does take into account the viscosity of the oil itself, but the NLGI rating is more of how well does that grease flow through a grease gun, and there's a specific measurement that they perform to determine how flowable a particular grease is. And that's called a grease penetration test. And there's actually an ASTM standard, D217, doesn't mean much to you or I, but there is a a formal way to test the flowability of grease, and it's called a penetration test. And what you're seeing there, the stuff in red is a sample of grease. It's in a little container, and you'll notice that there's a little conical shape that what happens is we drop this plunger into a grease from a specific height, and we measure the amount of penetration or how deep that cone goes into the grease. And the scale that is used, the penetration scale, kind of in the middle of the column there, where it says 400 to 430, means that it would be 40.0 to 43.0 millimeters of penetration. So 40 millimeters is approximately a little over 1.5 inches. So under no pressure, under a free fall, something that is a grade 00 is going to fall further. And that's why you'll see that as you go from a 0 to a 6, the amount of penetration of that cone into the grease gets less and less. And you'll see there on the description, it goes from a semi-fluid form. For instance, a 000, which is not shown there, has even higher penetration, would be like cooking oil. And a NLGI 6 would be like brick grease, which would be like a block of Velveeta cheese. And so grease can be measured everything from pourable grease to something that is very, very difficult to penetrate. And literally brick grease would be something where you would take a knife and literally peel it off to be able to apply it to a particular industrial application. Here gives you a different look at the NLGI grade and a little bit about the description and some of the applications. Since we're talking about bearings here, the most popular NLGI number by a mile is NLGI number 2. Most bearing applications will use NLGI number 2 grease, whether that's the standard grease in a sealed or shielded ball bearing, but even in cylindrical roller bearings and most other types of bearings, you're going to see a number 2 grease being the most common used. You occasionally might see a number 1, which is a little softer, and sometimes where you have bearings that are very close together, like in a needle bearing, you might see a number 1 grease because it's a little softer and can kind of work its way in between the needles, especially in a full complement bearing design. A number 3 grease will be also occasionally used. It's a little bit thicker, and sometimes on high-speed bearing applications, you can use a little thicker grease so that it's less prone to be flung out of the bearing under high speeds. But usually for most bearing applications, you're using the number 2, occasionally a number 1 or 3. The 0s and the 4s or 5s and 6s are all going to be for applications that aren't bearing applications. They're going to be used for other types of things like gears or hinges or a lot of other types of applications that aren't necessarily rolling element bearings. Another measurement that the NLGI also looks at is the grease drop point, which sometimes is called the melting point of a grease as well. It technically is the point at which the temperature is going, or the grease itself is going to pass from a semi-solid state to a liquid state. And one of the big misconceptions is that if a grease tube says that this grease has a drop point of 350 degrees, you really don't want to use it in an application where it's going to see 350 degrees. If you look at the last statement on this page, you want to select a grease so that its drop point is somewhere between 100 and 150 degrees Fahrenheit greater than the actual application. So if you have an application where you're going to be around boiling water that's boiling at 212 degrees, you would not want to use a 250 degree grease because the grease will start to soften and melt well below 250. Actually, it'll start softening at about 150. So it means the grease is going to start running out of the application when the water is boiling near it, and you're going to end up with bearings with no grease in them at all. So very important that you don't use the temperature on a grease tube, which is typically expressed as a drop or melting point, but just realize that you can only go less than 100 degrees less than that to be safe and not have your grease dissolve and melt out of that particular application. So what's wrong with this picture? So if you look carefully, what that is, it's a grease fitting in the middle where that green stuff is. And this shows you, I'm looking at this a couple of different ways. One, if you look at the upper left-hand corner, kind of northwest of that grease fitting, you'll see some dark amber stuff, which is also grease. And then if you look almost due east, maybe east-northeast, you'll see some grease that's kind of white. And then, of course, right over the grease fitting, you've got some grease that's green. So what this tells me is that the person who's doing this isn't using the same grease gun all of the time. And what they're potentially doing is causing incompatibility by mixing greases of different types with each other. Now, I will say that grease color by itself is not an indicator of the base type. You can get, for instance, a polyurea in green, which is probably what this is, but you can also get it in blue, and you can get it in red, and you can also get it in amber. So color is not a good indicator of the base of the grease, but in a particular plant, it's very common to have multiple greases for multiple applications. And even if a customer has a preventative maintenance program, somebody who is on first shift might like a particular type of grease and uses that when they're making their way around the plant, and they might be using a polyurea, that's green grease. And somebody else might say, you know what, I like this stuff, it's lithium and it's kind of amber in color, and I'm going to make my way around the plant and put that in. And what you could potentially have happen is you could mix greases of multiple bases. And if you do that, you're going to see on the next slide that you're going to run into an incompatibility problem. This is a pretty complicated chart, but it's much easier to read than you think it is. So let's pretend that we have an application, a bearing application with regular polyurea in that bearing. So if you look in the left-hand column, you'll see near the bottom, polyurea conventional. And let's say someone grabs a grease gun, and that grease gun has lithium complex in it, which is up in the top. It's the third column from the right. If you go down that chart where the two boxes intersect, you're going to see it's red, and it says it's non-compatible or not compatible. What does that mean? It means those two bases don't get along. And really, when you put them together, they typically have some type of chemical reaction to each other. And usually one of two things will happen. One is all of the oil will during the process of the greases breaking down because they're not compatible, the whole grease and oil become very soupy, and everything runs out of the bearing, and you're left with nothing in it. So if you go back to the very first slide we talked about, when you have metal-to-metal contact and you have no grease in between those two bearings, you're going to have a lot of metal fatigue happening immediately, and you're going to get catastrophic bearing failure. The other thing that can happen is the two greases mix together and they turn solid like a rock. Sometimes I've seen failed bearings where you open them up and it has this dark black substance that looks like shale. And all of the oil will run out of that, and all that's left is the base, which has no lubrication properties at all. So having incompatible greases is really a problem. One of the newest inventions, if you will, in the grease world was polyurea shear stable. If you look at the bottom row, you'll notice that on every single type of grease, it's either green or there's a couple that are yellow. And the barium complex and the clay non-soap are the only ones that yellow. And honestly, both of those are not very common. Polyurea shear stable is a grease that was developed by ExxonMobil called Polyrex EM. There are many companies that have also developed their own formulation of that. But a shear stable grease means that it's got much higher load capability than the old polyurea conventional. The big advantage, though, is if I had a customer who was lubricating a bearing application with lithium complex, and I used inadvertently a polyurea shear stable in that same application, it's compatible. So it's kind of a miracle grease. And so Most bearing companies today, in fact, I will say virtually all bearing companies today, on their shielded and sealed bearings now use polyurea shear stable as their standard grease. Why? Because if someone who's repairing a piece of equipment happens to pop a shield or a seal and puts, which means that the bearing will already have that polyurea shear stable in it, and they happen to lubricate their standard grease in the Planus lithium complex, they will not cause the bearing to fail because of grease compatibility. So it's a really important revelation that's really only taken place in the last 10 to 15 years since ExxonMobil developed that formulation. So in my travels, one of the things that I found is that bearing lubrication constitutes about 50% of the reasons that bearings fail. Could be either not enough grease, too much grease, wrong kind of grease, or compatibility issues. And so it's very, very important for you to understand that certain conditions exist where you may want to use less or more grease. For example, in a ball bearing coming from a bearing factory with shields or seals on it, you're most likely going to see fill rates between 25 and 40%, or an average of about a third fill. And in general, bearings should be about 1/3 full fill of grease at 50% of its operating speed. If a bearing's going to be going slower, you can see that it could be half up to half full at 50% of its rated speed, meaning that the rule of thumb is the faster the bearing goes, the less grease you use. And that's a concept that a lot of people don't understand. And one of the things that doesn't show on this slide, but in a spindle bearing, a machine tool spindle, the bearings that are utilized are very, very high speed bearings, could be running at 10,000 or 15 or 20,000 RPM. In those kind of applications, the fill rates on those kind of bearings could be as low as 10 or 15%. And so, again, remember that rule of thumb. Faster it goes, the less grease you want to use. And typically, the thicker the grease you can use. Very few bearings should ever be fully packed with grease. In fact, the only one that I would ever recommend would be a tapered roller bearing, because tapered roller bearings, by the virtue and the nature of the way that they're designed, there's plenty of room between the rollers and the cup and the cage to be able to purge that bearing effectively. So a bearing that is 100% full at when the bearing's packed initially, when you get up to operating temperature and operating speed, the bearing will be self-purging, because the rollers make an angle to the cup, and the grease will naturally bleed out of the bearing. It says that you cannot over lubricate a bushing, but you can waste grease and create a mess. So there are some applications, like a bushing, which is a non-rolling element bearing, perhaps made out of 660 bronze, where having it 100% full is perfectly fine. In fact, you've got to make sure, since a bushing has not only line contact like a roller, but actually plane contact, where the shaft conceivably would come metal-to-metal contact throughout the entire sleeve. You want grease to be everywhere inside that bushing, but there is a point where you're going to potentially waste grease. Another thing that says, don't purge water from a bearing by over lubricating it, because you could potentially damage the seals. We see this in mounted unit applications like pillow blocks, where someone will, they have a PM program, and their PM person says, every time, every 3 months, we want you to go ahead and throw 3 shots of grease from your grease gun in this pillow block. Well, if it's a small pillow block and you do that, you could potentially have enough pressure to blow out the seals in the bearing, and that will cause the bearing to be able to get contamination in there much more easily. If you are purging a bearing, or you are relubricating a bearing, if you have the ability to do so while you're pulling out a purge plug, most industrial equipment that is grease lubricated will have some type of plug or fitting where you can actually remove that, and you can lubricate and pump grease into the application. You want to allow and see the old grease coming out, and you ideally want to go ahead and keep doing that until new grease is coming out. And then, rather than closing up the purge plug, you're going to want to go ahead and let that run with the plug out for some period of time until your flow rate dissipates a little bit, and then you'll know that you've purged the excessive grease and you still have grease in your bearings. This is a picture. It's kind of hard to see, but one of the common conditions that we see with electric motors, and you can see kind of in the middle of the screen, this is a bearing. This looks like a shielded bearing here. So someone has actually pumped this end bell full of grease, and there wasn't an adequate protection from the inside of the end bell into the windings of the motor, which are kind of, you can see these kind of reddish looking things here. That's the windings. And they've actually pumped so much grease in there that the grease will actually get into the windings and cause the motor to short out. And so over greasing a bearing, particularly a bearing that isn't an open bearing where it's already shielded or sealed, that the extra grease that you put in is really not going to get into that bearing. There's a very small gap between the shield and the inner race of that bearing. And so even though the motor manufacturer might say, we want you to go ahead and put a little bit of grease in the bearing cap, this is the bearing cavity right here, and it might allow for a little bit, by continuing to pump grease in there, you're going to potentially ruin your electric motor. So this slide is talking about lubrication frequency. And you can see that there's two different ways to lubricate a bearing. One is to manually lubricate it, perhaps using a grease gun. And the other way would be to use automatic lubrication. And under automatic lubrication, they're showing the word PERMA here. PERMA is a manufacturer of auxiliary greasing equipment. So what we're looking at here is we're looking at frequency of lubrication and how that might impact bearing life. There's two ways to lubricate bearings. One would be manual lubrication, where someone would take a grease gun and put 1, 2 more pumps into a grease fitting manually. Another way to do that is to use an automatic grease lubricator. And that would be something that the grease fitting out of the particular piece of equipment could be removed. An automatic grease lubricator that has a fill or reservoir of grease could be screwed in there. And through either gas pressure or spring pressure, you can have a constant flow of grease over a period of time. And what we're showing here is two different graphs. The one in black, which kind of looks like a pumpkin's mouth in terms of teeth, you can see that the amount of grease could be over or under lubrication if you're relying on somebody manually doing that. And also the amount of frequency here, we've got less time, and then here we've got more time between lubrication, and we've got a short interval here. So what manual lubrication, even if a person has or a company has a PM program, tends to be quite irregular in terms of how often that a bearing might be lubricated, and also how much grease you're actually administering it. Sometimes, depending on the person doing the PM, they could be putting too much, and sometimes they could be putting not enough. So automatic grease lubricators, what they can do is by having something that is permanently attached to the bearing housing, you'll see that the flow of distribution can be very regular. When the bearing is consuming grease and comes down in terms of the available space in that bearing, the pressure in that lubricator will cause more grease to be administered, and you'll see the peaks in terms of how much grease or the valleys in terms of how little grease might be in the bearing. That's a fairly narrow range, and it's always within the optimum percentage fill rate. So automatic grease lubricators are a great alternative to manual lubrication, and PERMA is just one of the companies that makes those. And in fact, you can get automatic bearing lubricators from almost every bearing manufacturer. They will offer a line, some of them made by PERMA, to be able to administer automatic lubrication to your bearings. Another way to enhance lubrication life is to consider using synthetics. I know that when synthetics came out for automobiles, Mobil 1 was a real popular synthetic, and that oil cost 4 or 5 times what a normal quart of oil. But if you take a look at what the advantages are in synthetics, it might be something that your customer might want to consider when they're choosing a lubricant. And some of the advantages of synthetics over standard mineral oils are viscosity index. You could have a higher viscosity index, meaning that when the temperature rise, the oils won't thin out as much as they will with a standard mineral oil. If fire or explosive environments exist, synthetics can lower or actually raise the flash point so that the grease won't ignite at low temperatures, and it could make for a safer environment for workers by using a synthetic grease. Also, at low temperatures, pour points, flow rates. So sometimes, again, if you have a thick viscosity liquid and you have it outside in an outside environment in the wintertime in the northern states, the flow rate's going to be very slow, and in low temperatures you may not have sufficient flow rate to be able to adequately lubricate the application. So synthetics can stay more liquid and pourable in lower temperatures. And then also better oxidation stability. So just like metal will oxidize, greases oxidize as well. And by having special additives in synthetics, you can resist breakdown of grease due to oxidation. Let's take a look and review what advantages synthetics have. We've just kind of talked about you can go longer between lubrication or have longer intervals, which actually saves money, saves grease. The machinery can run cooler when it's hot outside. It can run more pourable when it's cold outside. Oxidation is reduced as well, so the grease will not break down or oil will not break down due to oxidation or oxygen affecting that. Less fire risk, more safe for employees. No VOCs, no volatile organic compounds, meaning there are some things that are hazardous when you breathe them, and so there's no VOCs from synthetics, where sometimes in certain environments, some greases or oils can emit a high level of VOCs, which means that people are gonna smell that grease, and in some cases can be absorbed into the atmosphere and be more prone to fire or flash. And then finally, reduced disposal costs. Some of the synthetics can be such where it doesn't create a hazardous environment if for some reason they leak out of a particular piece of equipment. Okay, so we've talked a lot today about grease. If you have any other questions, I suggest that you contact any one of the BSA member companies, and all of us have people who are knowledgeable about lubrication, specifically for bearings. And I would like to thank you for your time today, and I want to encourage you, if you need more education on other topics related to bearings, to consult the BSA or the Bearing Specialists Association for other topics that are covered in its educational series. Thank you very much. Take care and have a great day.
Thank you for your interest in learning more about the bearing industry. In addition to the online video training modules, you may also be interested in the Certified Bearing Specialist program, commonly referred to as CBS. As a distributor of bearings, I've been a certified bearing specialist and a CBS trainer for many years. This helped me in my career and has been a very rewarding experience. So why would you want to consider becoming CBS certified? 1, we work in a very competitive industry, and differentiating yourself and your company can give you that competitive edge. Product expertise will always be a primary decision criterion that end users will evaluate. Enhance your personal brand as a bearing expert by becoming CBS certified. 2, your ability to identify cost savings through product life extension and continuous reduction of a customer's overall cost will help with retention of long-term customer relationships. Enhance your company's brand as a solutions provider. I encourage you to visit the BSA website and review the application requirements to begin your journey in becoming a certified bearing specialist.
We hope that this training module is valuable for you, and if you're interested in expanding your knowledge even further, please consider becoming a Certified Bearing Specialist, or CBS. The Certified Bearing Specialist curriculum has helped me grow my understanding of how bearings are used in a variety of different applications and has allowed me to be more of an effective instructor to my customers and my employees. So why would others within your company or yourself want to become a CBS? For one, it'll enhance your professionalism and credibility when you're talking to your customers. When you're asked to troubleshoot a problem, you'll have greater confidence to provide alternative solutions. Secondly, many organizations do not have the internal resources to be able to provide advanced training on products we sell as distributors or manufacturers. The CBS Study Guide can be utilized as a tool to ensure your sales force is continually learning about the products that your company represents. I encourage you to visit the BSA website and review the application requirements to begin your journey in becoming a certified bearing specialist.
For manufacturers within our industry, one of the greatest values that the CBS training and certification can provide is a broader understanding of all the types of bearings that your field employees will encounter when calling on the various types of customers in our industry. So this really goes beyond just the products made by your company, and in turn makes your knowledge base more valuable to both the distributor and to the end user. For managers, having your employees go through the CBS process is a great way to invest in them personally because you're investing in their continuing education. Expanding their knowledge is always something that creates more value for an individual, especially when it's directly related to more practical product and application knowledge. This allows them to deliver solutions and create savings for the customer. We talk frequently in BSA circles about knowledge being one of the most important ways that both distributors and manufacturers can differentiate from companies that focus most of their energy in just e-commerce, but are not really able to provide solutions. Our company is investing in our first 2 certified bearing specialists, and I'm personally excited to see what types of positive impacts this has on their customer engagements and their personal success.